okay, if I change any of this, this is going to fire an automation in my environment. Which service am I going to affect? If we change the customer to CE, which service, which network service are we going to affect? There we are. So we are going to affect this service here. And this is how it maps to the service. So we can see that the payments partner VPN is going to be affected. Because your AI is only as good as your network automation baseline. The building blocks that we're going to see today for your agent that it needs to operate in your network are the same ones that a mature, a scalable network automation is built on. So we are going to today be taking a look deeper at this model that was proposed by the Network Automation Forum and try to understand how to build our automation. And the foundation that we want to understand today is the intent. This is not only the outcomes that you want. You want to express these outcomes, this intent in policies, in contracts, in variants. What should we be evaluating against in our network to make sure that we can automate, that our AI also can understand our intentions, our reachability intentions, security intentions, the observability intentions, because in the end, the network automation is more than just rendering the configuration that is what we think we must configure to reach those intentions, but really understanding how this will work in the automation ecosystem. So this here is the Network Automation Forum framework. And in their words, this is a modular vendor neutral framework that we're going to use to define high-level building blocks that are going to be necessary for us to design, implement, and refine our automation strategies. This is both a starting point and a guide for evolving existing solutions. Here, they have been developing this and it has been through some changes. Let me bring here, for example, how it initially was. So we can see the first version that was proposed. And we see that even though it's pretty similar, some wording here have changing and is not purely cosmetic. Why? You see that the orchestration layer is kept, even though we have created some building blocks that gives us the what might be going under this bigger directive, right? We have the automation engine that is basically here our execution layer. We have the telemetry and observability that we can see here, and it was also broken down to the observability and collector. And we have the intention that was initially here our source of truth. And you see that previously the source of truth was defined here with the baseline of inventory, the SIM, IPAM, the circuits, and it was broken down into this, it had this rebranding of intent, which actually makes a lot of sense. And we're going to be digging deeper into what does this actually mean and how do we implement this in a massive network automation environment. Because think that you're going to have to automate and take care of a network that looks something like this. You have many data centers spread across the globe, right? With spine and leaves architecture, with their edges, with connections to different sites, to different environments, to a core. How are you going to manage all of this when we're talking of thousands of devices and avoid the network becoming tribal knowledge, or that who has been here the most will be able to understand, to mitigate problems, and to automate? So our idea is that we can be able to model this in a way that's pretty clear and understandable for us to create automations to understand what would happen in a change and how we're going to build this automation. So let's take a look on this framework with a little bit more detail before we really dig into it. The idea of this framework is that it is divided by roles. So we have a role for observability, for collector. This doesn't mean that everything here has to be completely separated in the terms of different servers or different environments or different teams. But this gives us this idea of breaking down our efforts into roles. Who is responsible for what? So, for example, the observability was broken down into observability and collector. Why? Because the collector is responsible for collecting the SNMP via GNMI, any type of telemetry, syslogs. We're going to read this data, enrich it, normalize via the different methods that we are uh, collecting. We're going to put into a queue, and then we're going to bring here to the observability how we're going to store this data and create the logic for our analytics. Then let's go to the orchestrator. This guy is completely responsible for creating the plans or the events, reacting to events, and creating when should a workflow be fired, when should we trigger a pipeline. We're going to try to understand the change windows, retry methods, the capability of our devices, the strategy that we're going to deploy something, and we are going to write here to the executor. Here is the one that is really responsible for executing the writing the operations. And it's very common for you to see the orchestrating and executing kind of blended in together. And in future episodes, we're going to take a deeper look on how we can create this orchestration and also break it down into more steps and an architecture for us to build such tool with orchestration and executor. And then we have the intent. So, for example, the intent, we have some platforms that are created here, like SOT, and we have sources of truth that are very good at to answer the questions: what is our network made of? So, for example, we have Netbox, we have Nautabot, we have InfraHub, and here we are bringing basically our inventory, the devices that we have, the sites, where does this device belongs to, what are the vendors that are taking care of it, the platform, the device types, the manufacturing interfaces, our IP address management, our data center infrastructure management, the services that we have available. And we also have the option here, for example, on how to configure those devices. We can give it contexts with variable data. So we can take a look, for example, here, configuring the context that this bunch of variables and data comes from a GitHub somewhere, and we can create some Jinja templates for this device based on the role. It would have this golden config, the config would be rendered, and then we would deliver to the device. But this, we're modeling how to configure the device instead of modeling what the network is meant to provide, or this is how we think we have to configure this device to reach the intention. But is there any intention defined here? Not really. Can I understand if I change this, will I be breaking any of my contracts? Will I be breaking any of my invariants? Do I even know how to write them here? I need something better. What if I change uh, something on this device? Which sites will it affect? Which customer do I have to call? These are questions that when you're building automation at scale and also you want to give AI access to your network, must be very easy for you to answer. And how are we going to answer that? Okay, answers here, InfraHub. It is a source of truth. It answered the question, what is my uh, network made of? I have my inventory here, but the idea is that I am the one that is building this specific to my use cases. So with this, I can create what are my intentions. I can create policies. I can create intentions based on what are my routing intentions, reachability intentions, security, observability. What are my contracts? Let's take a look at this. And what if, right? So, for example, I have here my devices. I have my services that I just defined. Okay, I want to define services. This model is mine. So I'm the one who built it and I'm the one to maintain it, right? So let's take a look how this would look like, right? I will dig deeper into InfraHub in a future series, but okay, so I decided to create my network service, right? So I have my payments for the partner VPN, I have my CCTV backup, my payments backend database. Okay, if I do a change on my routing contract, which service would be affected? Which site would be affected? Who am I going to call? So, for example, I have here all my intentions. I have my routing contract, my tenant intent, the observability that we have to be building for each tenant, the reachability that each tenant would need to have. So let's take a look, for example, the observability signals that we're going to look for each one of my customers on the route, on the session state. What am I expecting on my session? Also for my uh, observability, right? What am I trying to achieve? Okay, so we can take a look. If I change, for example, one of these routing contracts, we have some route contracts for the customer to P. Let's take a look. Here we define what networks can a customer allow to receive, which zones it is denied to access the PE devices that are attached to this customer and the maximum number of prefixes. Okay, if I change any of this, this is going to fire an automation in my environment. Which service am I going to affect? We have on this InfraHub a path traversal, and it's going to answer for me just that. So I'm going to create this dependency. I'm going to check here, what is my intention. And we are going to see our routing contract. If we change the customer to CE, which service, which network service are we going to affect? There we are. So we are going to affect this service here. And this is how it maps to the service. So we can see that the payments partner VPN is going to be affected because if I change that. Right, interesting. So also which sites are running this VPN services and would also be affected. Okay, let's go back there again. Back traversal. We're going to create our intent and the routing contract. If we change the contract, we're going to see the location, which site locations are we going to affect. And there we are. We're going to affect only our EMEA POP A. That's pretty cool, right? So this is already something that you can see helping you plan and helping AI understand the blast radius that you're going to have. Now, let's take a look then. What else are we trying to achieve when we are bringing this intention? So let's take a look here. What differentiates a source of truth and makes it become my intention, right? So the source of truth is really answering what are we made of. But the intention really has to be the one who holds the truth, the one who holds the outcome that we want to achieve. So this is what we're going to be aiming at, the outcome. And for this, we need a platform that will gives us the flexibility to write what are the outcomes for our specific scenario, for our network. And eventually you need a platform either that is going to, you're going to go to Git or you're going to start writing on your wikis. But this is not good enough for your AI or not flexible enough for you to also verify early and create constraints and even trying to create this before it triggers an orchestrator. So you want to bring it as close as possible next to the source of truth. This would be ideal because here on the outcome, how are we going to do this? We're going to create policies, right? And under these policies, we can define, for example, here we create routing policies. We're going to create our reachability policies. We're going to write our security policies. We're going to write our observability. And we're going to enforce them, creating contracts and invariants. Here, we're going to try to understand, for example, in our routing, what are the communities that we're going to expose? What are the export rules for a given tenant, for a given site? What are the allowed prefixes that they are allowed to receive? Well, on the reachability, what are the allowed what are the prefixes that they can reach? What are the on the security? Are the allowed rules that will convert into our access rules or into a firewall policy? You see that when we are writing our intent, we're not writing with a vendor. We are going to write this in a way that is completely human readable and what our network really expects. And then we're going to put to the orchestrator to create the planning and to convert this to really compile and render the config and how we're going to achieve this. Then we're going to create our observability. What are the required signals? What are the capability that a device must have to reach our network or this site or this specific role? What are, when a device comes to our source of truth, where must it be? How it must be rendered? Do we, where it must be now reaching, added to our collector? This is what we're going to do. And this is going to, in the end, reach this compilation. We're going to compile and then render the configs, the policies, and so on. So this is what we are doing, and this is what it would look like. So for example, right, let's take a look. Let's take a look at what it would look like, right? So for example, if I add a new device or if I change the capability of a device. So for example, let's take a look here, one of my devices. And you see here we have the on the OSXC, for example, if you go here to the side, we're going to see that we don't have GNMI. So two things, but we do have netconf. So interesting here that you see that the capabilities are going to change for more than one thing. So first of all, let's add GNMI here. And what I want to do here is not document only the capabilities. This has to reflect somewhere, and it's going to reflect based on my intentions. So two things, for example, if I have netconf or if I have GNMI, for GNMI on my intent for my observability, I want now this device to be added to the collector to start collecting this data, also start processing the data on the observability. I want it has to reflect then that this will be added. And with netconf, for example, when we dispatch now a workflow, it's going to change on my orchestrator. If my orchestrator is planning or deciding the capacity of my devices or picking the strategy, are we going to, is my device capable of doing dry runs, of doing a commit confirm, of doing a transaction or doing atomicity? I want this. So the capacity here is going to change how my orchestrator is going to behave. And I can't verify this based on my intention. I have rules here, I have contracts that my orchestrator has to follow. So let's create here a proposed change. Right, we're going to create here a proposed change for from capability to main, so we can try to understand first iOS XZ GNMI. We are going to try to understand first if this change is compliant with all the our intention, if it complies to our contract, to all of our policies. So you see first that we have a data integrity. The data that we're going to change here, we're changing the capability of Cisco SXC, adding GNMI. That's very nice. We already see that we changed some artifacts. Why is that? Because now on the telegraph, I'm adding here as a comment that we are capable of GNMI. I would like to see also it being added here, or even better being added, for example, to GNMIC on our collector. And now my expectation on my contract is that it's going to be observed via GNMI because I have an order of precedence. If they have GNMI, I want it. Otherwise, we go with SNMP or something else. Or if it doesn't have anything, I will see that this device is not going to be monitored. And then on our checks, probably here we have a contract that on the observability expectations is that every device has to be somehow monitored. And then we can create specific validation. For example, our core devices has to be enable at least this type of values. So we can create one based on our intentions, what we want to be validated and if it is being validated, right? So you see that now we are passing through the capability check, and this is going to reflect on that change, for example, here on the route. After this, it's going to change the the telegraph input here on the router. It's going to have now the GNMI. And of course, I could better. This should bring some GNMI input already, and this would be, for example, something that your automation is going to be growing and getting more mature. With when you start seeing these gaps and you bring it, okay, no, it's not. It's going to be brought to the telegraph, or it's going to be brought to GNMIC, or whatever, and we're going to define all of this with the mechanisms that this platform gives us. For example, let's do the merge, right? Everything passed. So doing the merge, going to do the merge. It's going to go to through the checks again, and we go to the main. Another example, something really nice that I would like to show you guys before we wrap up. Okay, so we are going to change on our intention, our routing contract. Let's change this. On our customer C to PE, let's say, we're going to announce a new network, a new prefix. Let me see if we have a new prefix, IP prefixes. Okay, let's create a new one. Capability. Let's put this one is going to be prefix. And I want to show you guys something. So for example, let's say we are changing here. We're going to add a new prefix. So we're going to say active. The prefix is going to be 192.168.0.0/24, right? We're going to create here that this is from the customer C, and we're not going to yet assign to any VRF, right? This is just one of the one of the pools, right? So we're going to come here on the intent and on the routing contract. I want this customer C2P, and we are going to allow this prefix here, this new prefix. Okay, so we're going to allow, where is it? Allow. Ah, small bug, right? How did I click it? Yeah, 192. Okay, 192, there it is. We're going to save and we're going to allow this prefix. So let's propose a new change. Again, from the prefix, new prefix allowed. Right, so let's create here. Let's see it passing all the checks or not, and the changes that it would go through. So there you go, starting tests. Let's wait for a little bit. There you go, contract expectations, device configuration, if anything is going to change. For now, things are passing, and we should see an issue with the contract prefix authorization check. Let's let them run. Capability, observability. Yeah, there you go. You see that we have a check on the customer C2PE that when we have one invariant that was violated, the prefix authorization contract customer C authorizes this, which is outside every single segment owned by the tenant customer C. So we have an issue here that is this segment does not belong to customer C. So even if we did want to merge, you see that it should, propose change because it has some failing checks. So what are we going to do? What happened? This IP address prefix that we're announcing, it is outside of the VRF, right? So if we say that it is on the VRF, it means that it belongs to customer C. So let's add this guy to the customer C VRF. And this should now pass on our change. So we're going to open here again and ask it to, where is it? Refresh diff. Yeah, this is what we want. Okay. And we have the VRF here. So now it should kick in, retry all the tests, and we should see, I am in front of it, right? We should see this test passing which now is with the message of the violation. So let's take a look. And you see that we are going to change here the configuration on the devices. So on the C, we're going to have the network on this bunch of on this Nokia devices, right? On the customer C2, right? On the provider edge, we are now on the contract expectations to see this network there. On the device configuration, now we're going to permit receiving this prefix from the customer, right? On both sides of them. And then this is going to be dispatched. I mean, naturally here we are this is a lab, so we're doing the customer configuration also, but in our, say, in our environment, you would find the corresponding, you get the idea, right? So yeah, it's ran again, and now we have all the checks passing. We are now able to merge. And there you go, we are going to be able to merge. On the next videos, I am going to dig deeper on how to create these transformations that are going to convert into these artifacts, the configurations, how to create and improve. I think my intent here is still a little raw. I have to do some improvements on it. And it is a lot of work. Yeah, naturally, it is a lot of work. Doing network automation properly, we're not even scratching the surface. We're going to take a look on the next one, on the orchestration and on the execution. How do we start in a workflow, a pipeline, and what if and how to observe it. What if in the middle of the pipeline something goes not in our favor or not was not predicted? How do we stop it in the middle of the pipeline? How do we roll back? How do we do the validation, the planning? It has to go through many of the checks. We're going to see all of this. How do we go from this rendering configs to pushing them? And this is going to be a lot of fun, right? Hopefully you enjoyed and see you on the next one.